multiply fractions and mixed numbers. Okay. Now, when we take a look at multiplying fractions and mixed numbers, for today, when we add and subtract with fractions, they needed common denominators. When we multiply with fractions or mixed numbers, everything has to be in, right, AB form, very good. Or we call it just fraction form, works the same way. But I like how you used A over B form, very good. Okay, so if it's not in fraction form, does it matter if the fraction's improper? Mm-mm. As long as I have a numerator and denominator, that does not matter. So 3/5 times a 1/4. I don't need common denominators. They're both in fraction form. What is it that I want to look for, though? I want to look diagonally, right, to see if they have anything else in common I can reduce them by. 3 and 4 don't have any of the same factors that I can divide them by. Neither do 1 and 5. So I just got to go straight across. 3 times 1. And then 5 times 4 is 20. And if 320 is in simplest form, then I'm good to go. Five sixths times a 4/5. Here again, I'm going to look diagonally to see if I can reduce beforehand. Why is it a good idea to reduce before you multiply, Chris?
So, like, if you reduce, just in case you reduce, you don't have to multiply, like it's high.
Okay, the numbers might not be as high, right, Keith? At the end, I'm not stuck with some huge fraction to try to simplify, right? I'm going to try to cut it down beforehand. So 5 and 5 both have 5 I can divide them by. 4 and 6, they're both even. So 2 and 3. 1 times 2 is 2. 3 times 1 is 3. 2/3 is in simplest form. Okay? Any questions on the regular fractions? What's up? Scroll up. Good. 1/4 of 12. Of means multiply. Okay? Now, I just have to make sure that I've got both of these factors in fraction form. 1/4 is good the way it is. How am I going to convert the whole number 12, Alex? 12 over 1. Now, that's standard. Anytime I have just a regular whole number, anytime I want to put it in fraction form, I just put a 1 underneath it. Okay? 4 and 12, they have 4, right? 1 there, 3 up top. 3 over 1 equals 3. Chris? Now, just flash back for a minute to the first lesson of the chapter. You remember what the first lesson of the chapter was? This book, 4:1. Alex? Sophia? Estimating, yes. Estimating the adding and subtracting and estimating and the multiplying and dividing. So we can use those tools and say, you know what? What is it that I should get something close to? 1 3/10 if I were using that estimation method, that rounding method. 3/10, is that half? No, so that would go to a 1. And 6 2/3 is 2/3 greater than half. So therefore that would round to, so I should get something in the neighborhood of 7 when I do the work. Now what I wrote in red won't be required of you for tomorrow. It's just something you can use as a tool. So I need to put these into fraction form. Whole number times the denominator is 10 plus the numerator, and the denominator stays the same. Whole number times the denominator is 18 plus the numerator, and the denominator again stays what it was. 20 and 10 both have 10 in common, therefore that's a 2 and that's a 1. 13 and 3, not so much. So 13 times 2 and 1 times 3. Do you have to simplify this? Yes, you do. How many times can we put 3 into 26? Which is 24. 8 and 2/3. Now, how does that compare to our estimate? Close enough. I mean, you have to also understand that this is going to be off by a little, because they're not really 1, and it's not really 7. But it gives you an idea. Okay? Try a couple. Very much review. 3 and 1/3 times 4, 1 and 1/4. And 2 1/2 times 1 3/5. 3 1/3 converts to what as an improper? 10/3, right? And then 1 1/4 converts to very good. 10 and 4 are both even. 5 and 2. So 25/6. 4 and 1/6. 2 1/2 converts to and 1 3/5. 5 and 5. 8 and 2 equals 4/1 is 4. Any issues? Any questions? Good to go? You should have the worksheet on the back of 4-3. Worksheet 4-4. Let's go 13 to 24. 12 problems. Redo. Through 15.